we're gonna define what two type of power series. So a power series. Hold on a second. Wait, why is not bigger? Okay. Power series is with a variable. So it's a series with a variable of x. And we already see that with the Taylor polynomial. That raised to the some type of power. N. Okay, that's raised some power n. And the summation is going to be like this. N equal to 0. Infinity. Now I'm going to show you a different color. This is a to the n to the x to the n. So for example, that's equal to a0, a1x, a2x squared, a3x to the cube. Okay. And this is a power series center at origin. So this is a power series center at origin. So this is the first part.
Power series
Center at origin, which is 0, 0. Now you can have this n equal to 0, summation, again, a n to the x minus c to the n. What do you think x minus c does? Center at where? So power series.
To the right. D to the right, yes, sir.
Center at x equal to c.
Yes, C to the right. Because it only offsets it. But it's exponential offset,
So the only thing difference between power series, like before the series, all the series we did is without x. Now we have x to the n. We did that with a Taylor polynomial for e to the x. Do you remember Taylor polynomial for the e to the x is? Does anybody remember? Huh? X to the n to the n factorial. Yeah, so that's the power series. So this we already showed the power series. We should do the other way around, but I did this way, just because I wanted you guys see power series first. Is that okay? So and so what do you think about center? Let's talk about what does that center do. Like, can you tell me what do you think the center does?
center meaning in this one.
What does the center mean to you at here? Okay, let's start with a series that we already know. So for example, e to the x, we know that e to the x is what? E to the x is a power series of summation of n equal to 0, infinity of xn over n factorial. We know that one. Well, you're supposed to know that one. If you don't know, you need to know it now. This is the easiest one. But that one is really hard to tell where the center is. Where the center is start at 0. Okay, so let's imagine that if you have this situation, I have sine of x. Does anybody remember what sine of x is? Or in terms of the power series? summation of n equal to 0, infinity,
-1 to the n
-1 to the n, good,
x to the 2n plus 1
x to the 2n plus 1,
over 2n plus 1.
2n plus 1, factorial. Now here's my question. Is this center at where?
That one. I don't know.
This center at where? I'm gonna ask again. Where does the center at?
Wait, I think I see a pattern here. Could you zoom out? Oh, actually, I have the notes right here.
Where do you think the center is?
Is it
Uh,
one?
can
One,
I-
two?
Yes.
No, that's the wrong half number.
Alejandro, can you explain why it's 0?
X minus c to the n. N is still the exponent. It's unchanged. It's the constant that's being put to the power that needs to change.
Right.
Well, yeah.
So that just show you what happened, right? So we know on Desmos that we know that is let me see, is -1 to the n, right? And what's the other one? X to the 2n to the 2n plus 1, n plus 1, divided by.
You might want to parentheses that.
You're right. And divided by what?
2n plus 1 factorial.
So it'd be 2n plus 1 factorial. And a lot of people don't understand what center mean, including when I was a student. I was like, what the hell does center mean?
I've
but-
asked that question. I don't know what it means.
So this one is gonna be this, right? It's center at 0, right?
Because it's
Shh, let me talk. If I ask you to talk, I will tell you. Say, Ian, please talk.
I'm trying to talk to myself. But
Okay, then don't let anybody hear it. I don't have the energy. I'm sick and I'm tired. And I'm just don't have the energy to put up nonsense. So you see the center is at 0. Now what if I change it to that says minus pi over 3? I say it's minus pi over 3. What is my center at right now? It's at pi over 3, right? So if you do just type in sine of pi over 3, guess what? It's the exact same graph. That means you start at exactly at x equal to pi over 3. X equal to pi over 3. You start like this and you expand it that way. So now you know where the center. Center is going to be start from there, you're readjusting all the graph, but that's your center. So that in the middle region where the center is the most accurate within like a small amount of iterations, right? So if I make it to, let's say, 100 iteration, then it will be very good. It will not have issue. But it start with here. It's not start with sine of x, because sine of x is going to look like this. It doesn't start there, but you know it start at this the point where I shifted my center. I recalibrate due to the center is that location. Does that make sense? So a lot of people don't understand what the center mean. This is what the center mean. Yes, Ian.
I was just going to ask if you could zoom out on a lower thing than 100, just so we could see.
It's pretty accurate. Even to the here, because that's a shift. So even 100 is enough to be very, very precise as far as on calculation goes. Let me erase this graph so that way you can tell. It's exactly the same, but it's based on this pi over 3 shift. So that means you're graphing sine of x minus pi over 3, which is shifting the graph right to the pi over 3. And that's why the center is important. So not all questions start at 0. I can start at somewhere else. I can have the shift of the graph. And the power series is going to represent that way. Is that okay? So now that you understand what a center is, but you gotta be able to write down like the power series. So learn to how to write out the first few term. So let's just say usually we will start at n equal to 0 and infinity of -1 x to the n over m factorial. So can you write out the first few term of power series? That's first four term. Bless you. So if I write out first term, for this first term here, 1, what's the second term?
Negative
X over
1.
factorial plus what? 2 factorial minus x to the third over 3 factorial and dot 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 dot. So if you have this, you gotta be able to write like this. Does that make sense? That becomes your power series. Okay. Can I have a power series look like this? N equal to 0, infinity, -1 to the n of x minus pi over 4 to the 2m plus 1 over 2m plus 1 factorial. What will be the first few term of power series?
I'm still trying to recall. Is that pi over 4?
Yeah. So this, let me ask you, is the center where? Center where?
Pi over 4 to the right.
Okay, what if I have plus pi over 4?
Then it would be to the left.
You'll be left. So it'll be minus, right? Your center is going to be x minus pi over 4. Basically, set whatever inside the parenthesis equal to 0, it's going to tell you where the center is. Is that okay? So let me plug in the first term. It's going to be x minus pi over 4 to the 1 factorial, right? Minus x minus pi over 4 to the third power over 3 factorial. Plus x minus pi over 4 to the fifth over 5 factorial. And dot 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 dot. So a lot of time that you want to write a reverse, if I have this, I can write it like this. This is called a general term, right? This is a power series.
And
Yes.
and the pi over 4, since it stays every time, that's why it's so consistent and repeats.
Yep.
Because it's inside doesn't change. Okay.
Mm-hmm.
Can we just stay on that for a minute so I can write
Sure.
it down?
Now here is the hardest part to understand. Even though a lot of people don't understand, even when I was a student, I don't understand why am I doing this. A lot of time, like Alejandra the other day is like, why are we doing this, right? So a lot of time I don't understand either, and no teacher ever like try to teach me those things. I'm gonna try the best I can, but I don't know if I can. But I'm gonna try the best I can. So the power series create a function of x and this function is going to be f of x is equal to summation of n equal to 0 to infinity of a n to the x minus c to the n. This is center, right? But you have to understand with the domain of all x such that summation of a n to the x minus c to the n, it has to be converged. So the x that you plug in has to cause series to converge to be represented as a function of f of x. If the x you plug in causing diverge is no longer can represent as a function. Does that make sense or no? So whatever x you plug in, the series has to converge. So you have to have some interval of range of number. Sometimes the range of number could be a single point, could be a infinite from negative infinity to positive infinity, could be only from like say -1 to 1. Okay, it could be from -3 to +8, something like that. It can possibly have that. That only work at this range. It doesn't work with any other range, but only in this range. But the thing is, it must need to converge. If it's diverge, okay, if diverge, then it cannot represent as a function as f of x. It cannot represent as a function because if things go diverge, then it cannot be as a function. So this is a power series. So we're gonna start with the easiest power series that we can think of. This power series, actually, you already know, but it takes a while to think about it. It's n equal to 0 to infinity of x to the n. So if I write out first few terms, what would it be?
X.
No, you start at 0.
Oh, 1.
1 plus. Now, do you think, this is a hard one now. I'm going to ask you to think about this one. No. What do you think this power series represent which function? It's very hard to think about this. But I want you to challenge it. Maybe one of you guys can figure out. What will be this function representing 1 plus x squared plus x cubed plus x to the 4th plus x to the n? What will be this represent us? If I would name a function, for example, e of x, right? We know is x to the 1 factorial. You start 1 plus x over 1 factorial, x to the 2 factorial. But what will be x to the n representing? What? No. Good try though. Sorry. This x to the n. If I would think about it, what will be the function represented by this power series? So for example, e to the x is equal to, let's say, 1 plus x over 1 factorial plus x2 over 2 factorial plus x3 over 3 factorial. But that's e to the x, right? But what would this represent as? We don't worry about domain. What will be this function represent? It's actually something you studied before. I won't give you, huh? No. Nope. It's algebra function. Nope. What? Nope. Nope. Yes. Who says geometric? You turn around and say, who says? Wait, geometric.
Geometric is just exponential.
Yeah, but no. No.
Oh?
No. Do you realize which each term multiplied by? X, right? So what would be the function? Okay, what would be this function of f of x is equal to? What would it be?
Oh, wait, I have an idea.
Remember, it's a1 over 1 minus r, right? What is a1 in here? What is R in here? 1 over 1 minus x. Do you see why that is?
No.
Because the ratio over here is what? R is equal to x. You multiply by x each time.
Yes.
But remember the convergent divergent situation. This function has some type of domain. What do you think domain is? The x has between which two values? No, halfway there. Why?
Because they
Make
can't.
a rule for infinite geometric series that has to be.
The r has to be what? R has to be less than 1. So that means what? The domain is going to be between -1 less than x less than 1. This can be represented as this only between those 2 points. Not anywhere else. Do you want to see it?
Yes.
Okay. Let's say summation. Oh, let's just do 1 over 1 over x. 1 over 1 minus x, right? It looks like this, right? And you're like, that doesn't make sense. 1 plus, look at this. 1 plus x squared plus x to the third plus x to the fourth
It becomes increasingly
plus
inaccurate.
x to the fifth plus x to the sixth plus x to the seventh plus x to the eighth. Oops. Like this, right? But look at it. It only inaccurate between which two values?
Well, weirdly enough, at -1, it kind of starts to freak out, but at 1,
It's only inaccurate between those two values, not anything else. It only worked on that special arrangement because we say the R, because geometrics, R has to be between less than 1 and had to be greater than 1. But less than, less than 1 and greater than -1. So it has to be between -1 and 1 in order for this function to work. Therefore, the x has to be between there in order to work. Does that make sense? Because if R is bigger, let's say it's 1.1, guess what? It's going to diverge. If the diverge is no longer can represent as a function. That's what we talk about. It has to be represented as a function. Jesus, you follow me? Or is only now? Yeah.
Following, not really understand.
one thing I'm looking at there is if you see the -1,
Because you're looking down.
if you look at the -1 part, there's actually a pretty big gap.
Yeah, let's just do this. Summation of, let's do summation between 1 sorry, between 0 between I can't do it. Summation of 0 to the 999 of what was the function? X to the n, right?
Yeah, I think so.
And if I go into
It's
Um,
blue.
it's a blue one. See, it's exactly like 1 over x, right? It's exactly 1 over x between -1 and 1. Not anything past that.
Well, can we zoom out just so we can see the
Yeah,
line
you
there?
can, but it doesn't follow anything. The green part is not within the domain. Remember, Jesus, what we're saying is we know that common ratio of this function is x, right? This is x. We multiply by x each time, right? So the x is represented here, right? But x is also the r. And r has to be between -1 and 1 in order for geometric series to work. Because if r is greater than 1, then its diverge is no longer can represent, the power series can no longer represent as a function. Only within a certain domain. So the domain matter here. Do you understand?
Yeah.
Yeah.
Jesus, do you understand? Are you sure? Okay. question about this part. I think this is really cool. I mean, I just cannot visualize why is like 1 over 1 minus x represented by a polynomial of 1 plus x squared plus x cubed plus x4x plus x6, whatever, x to the n. I just cannot envision that. I don't know who come up with this. It's a pure genius. I think it's a pure phenomenal. Like
Well, I mean,
people who can come up with this, they just have really clever thinking. Yes.
You can like factor out an x and then solve for the thing, and it gives you 1 over 1 minus x.
What do you mean?
Like if you take the 1 plus x squared plus x cubed, you factor out an x, it goes to 1 over x plus 1 plus x plus.
So you say factor out x, and what do you have?
And then you can solve for the function. You do like 2, because you can swap the 1 plus x squared for the function as well. So now there's
Can you write on the board over there? I cannot see.
I think I vaguely understand you conceptually, but I need to see what the other is.
I was coughing so much, we're coughing to my back.
It's the ones relating to the spinal column.
Oh, I see.
No, you don't. Stop.
It makes sense. It might make more sense when I can see it. Whoa.
And then you just.
You got no comment.
No, that's an interesting perspective.
How much? Oh my god. I could do it.
Mr. Day, if one day machines revolt, Desmos
What?
if one day machines rise up against humans, Desmos will immediately like crash out.
On me?
Yes.
Why?
Every single time we come in here, there's always like 1,000 functions over there. Like that poor Desmos will not have a break.
Hey,
Um,
someone
one-
say,
I was watching the interview. I was watching this TikTok short yesterday, and it was showing me like a trolley problem. Between they asked like Gemini or ChatGPT, like if they have a trolley and they will run over 3 people or kill all AI, and it was really interesting. Like AI is actually thinking about it, whether to save 3 people or kill all AI.
It depends on the individual survey.
One thing I find hilarious is that you know, Elon Musk is trying to make the Twitter AI like agree with whatever the hell he says, but the AI keeps ignoring him because he keeps saying things that are antithetical to the truth. The AI just keeps. It's like the opposite of evil AI they've buried under oh no goodness, and the evil always comes out. It's the other way around. You keep trying to make it evil, but it always keeps staying good.
Yeah.
Which is interesting. I think the first one said that he would have hit the server because the server can be repaired, whereas the people cannot.